Hi, my dear viewers. Welcome back to Future Not Bank live stream. And every week you are going to face this kind of extraordinary live stream. This will makes you in mathematics the perfect and gem. I will sure of it. Now after this visiting my class and visiting my live stream, you can understand yourself how much better thing we did. So watch the live stream till the end. In the middle, little bit 5 minutes gap will be there after 1 hour. And so, shall we start the real numbers over here? Complete chapter. And now see here, real numbers and the real numbers is nothing but it is a combination of real numbers is a completely is a combination of rational numbers and irrational numbers. Rational numbers and irrational numbers. Irrational numbers. Combination of these two we consider as real numbers. And you may get confusion. What is a rational number means? The rational number is nothing but which will be in P by Q form. P by Q form means, for example, 1 by 2, 3 by 7, 5 by 9, like this, etc. Which are in P by Q form, those all the numbers we are going to consider as rational numbers. And I think you got the clarity about the rational numbers. Now I'll go for irrational numbers. Irrational number in a sense is root 2, root 3, root 5. These are irrational numbers. And how can I will declare that irrational numbers means which are in the any number which is the square root of it, we call it the surd. These are surds. Surds means a square root of a number is called surd. So all the surds and everything else we are going to consider as irrational numbers. So now, first of all, I am coming back with that one. Euclid division lemma formula. Euclid division lemma formula here. What is that means? A is equal to B cube plus R. For example, I am going to give this one as 35 is going to be divided by 36 is going to be divided by 5. Here 7 5 are 35 and 1 which is remainder. Here the big one 35 is going to be the dividend, and which is we are dividing, that is called divisor B, and the quotient is 7 plus remainder is 1. Here 7 5 are 35 and plus 1, sorry, here this is the 36 is the number. So 7 5 35 35 plus 1 36. So this is a Euclid division lemma, for example I gave here, and here one important formula is there. R is greater than or equal to 0 and less than b. Here b is the divisor. Remainder always lesser than the divisor. You can see remainder is 1 here and this remainder is lesser than the divisor 5. So whenever the remainder came less than the divisor, then only we can consider this remainder and it will always be less than b divisor. But the remainder is equal to 0 sometimes and greater than 0 also. So here this is the second format. Now comes the point of one example I will take here. I will give you for you. And what is the what do you call applying this one 900 and 270. 900 270. Which is the bigger number here? 900 and which is going to be divided by 270 and in 3 operations it's going 810. Remainder is going to be 90. Here we will see that one Euclid's division lemma formula A is equals to B cube plus R. Here A is nothing but the dividend 900 and the divisor 270 and the quotient 3 and the remainder 90. And you can see here both right hand side and left hand side LHS and RHS should be equal. Then only we can consider this Euclid's division lemma formula here. Now 270 into 3 810. 810 plus 90 900. So 900 here 900 here. 900 equal to 900. So we justified the Euclid's division lemma formula. I think you note it down. Now we go for certain sums over here depending upon this same formula Euclid division lemma. Here first one I am giving here, use division algorithm, to show that any positive odd, here this is the word we have to stress here, odd, any positive odd integer, any positive odd integer is in the form of 6 cube plus 1 or 6 cube plus 3 or 6 cube plus 5, and where q is some integer, where q is some integer. This is the question you are going to face. And how to do this, how to solve this problem? Once again you see, use division algorithm to show that any positive odd integer. Here one more question will come, means how it will come? Use division algorithm to show that any positive even integer is a form of like that will come. Otherwise any positive cube of positive integer is in the form of any square of positive integers is in the form of. Like that, you have got problems you are going to face. Now we'll solve this problem by using that this one. What is the simply try to understand, try to learn this one. What is simply first step? First step is let A be any positive. Very simple. Within the question only you will get a step. Within the question only you will get a step here. Try to catch the one. Any positive odd integer. Odd integer. Any positive odd integer. And this is the step number 1. Step number 2 is let's we apply division algorithm. Division algorithm. Division algorithm with A and B. A and B, where B is equals to 6 here. And you will get confused maybe. Let me apply the division algorithm formula where A and B, but B is equals to 6 here. What is the B is equals to 6? How it has come means I will explain you in the next step. This is the first step is let A be any positive odd integer. Step number 2 is let me apply the division algorithm with the one integer A, another integer is B. That B is having certain value. Why the B is having certain value 6 here? I will show it in the question itself. You can see here in the question what is there here? 6 cube plus 3. That means 6 is in the place of B. A is equals to B cube plus R. That means in the place of the B, 6 is there. That power 6 is the B value here. So now we'll go in for that step number 3. Now, the step number 3 is the possible remainders. The possible reminders are 0, 1, 2, 3, 4, 5. These are the possible remainders. How can we say these are the possible remainders in the sense is you can see the remainder always be less than the divisor value. Remainder always be less than the divisor value. That means here divisor is 6. So it should be less, remainder should be less than 6. So that means 0, 1, 2, 3, 4, 5. So this is step number 3. Now step number 4 is all the possible A values. All the possible A values are here you can see and 6 cube. That means here remainder is 0. According to the remainders I am giving the A values 6 cube. Second one is 6 cube plus 1. That is whatever here it is there. Next 6 cube plus 2, 6 cube plus 3, 6 cube plus 4 and 6 cube plus 5. Here these are the A values. Why? Because how long the remainders are there? that many a values you are going to get. First one is 6 cube, because of remainder 0, there is no remainder here, remainder is not having value. And 6 cube plus 1 with the first remainder, 6 cube plus 2 second remainder, third one, fourth one and fifth one. And now the next step is now all possible a values I gave here. Now a values can't be. That means which are in this possible a values, which are a values can be, which are a values can be. These are the two steps are very important. That means a values దీంట్లో ఉన్నాయి, ఏ వాల్యూస్ ఏమున్నాయి, ఏ వాల్యూస్ కానివి ఏమున్నాయి అనేది క్లారిటీ అనేది ఉంది. The a values, the a values can't be are, a values can't be are here 6 cube plus 2, 6 cube plus 2 and 6 cube plus 4. Next, the a values can be, a values can be, what are the a values can be here? 6 cube plus 1, 6 cube plus 3 and 6 cube plus 5. These are a values. How can I say these are the a values? Why I am saying these are not a values? Why these are not a values means because he told in the question, show that any positive odd integer. 4 is not odd integer. That purpose this is not a value. 6 cube plus 4 is not a value. 2 is not odd integer. That purpose it is not a value. And 1 is an odd integer. That purpose it is a value. 6 cube plus 3, this is the a value and this one is a value. So these are the positive a values. So this is the one interesting sum before I am placing you. Okay, that will go for the next sum. Okay, now and one interesting sum I am going to place here before going to go for that very important sums. Check whether 6 and 6 to the power of n can end end here can end with digit 0, can end with the digit 0 for any natural number, for any natural number. Here see, check whether 6 to the power of n can be end with this 6 to the power of n can be end with now for this point of view solution I am giving here. question once again saying, check whether 6 to the power of n can end with the digit 0. Can end it with the digit 0 means that we are discussing here. Now, suppose 6 to the power of n is nothing but 2 into 3 to the power of n. 2 into 3 to the power of n, and the prime factors 2 and 3 we got here. 2 and 3 we got here. Now, what is the conclusion? To end this, what is saying? 6 to the power of n, then anything else. For example, 6 to the power of n means 6 to the power of 1, 6 to the power of 2, 6 to the power of 3, 6 to the power of 4, 6 to the power of 20. Whatever it may be, how many exponents the 6 is carrying, that should be end with the 0 or not means it is, we can think that one equivalent or not. To end with 0, with 0, 6 to the power of should have a prime factor, should have a prime factor 5 and 2, should have a prime factor 5 and 2. But here 5 and 2 not there. Here 2 and 3 are there. 5 and 2 the prime factors, this should 6 to the power of n is having me. That occasion the 6 to the power of n will have ended with 0. 6 to the power of n end with 0. In which occasion, if the 6 to the power of n should have the prime factors 5 and 2, but here 2 and 3. That purpose 6 to the power of n is cannot end with 0. Cannot end with 0. Now we'll come to the point of very important some more all the logarithms and proving of irrational numbers and everything in complete chapter I told you, a complete chapter I'm going to give. So now I will go to explain the logarithms one. First formula is log x plus log y is equals to log xy. An example is, I will give you an example for this one after log 2 and log 5 is equals to, and 2 into 5 means will get 10. So this is the example. That means xy means x into y. That means 2 into 5 we are going to get 10. So this is the logarithm formula number 1. And comes to the point of logarithm formula number 2. Log x minus log y is going to have log x by y. Log x by y. You can see here, first formula is log x into y, second formula is log x by y. So now we having this one, log x is suppose is 9, log y is suppose is what you call 5, and what we will have here, log 9 by 5. This is the example and answer for the second logarithm. Once again I have explained second formula. Log x minus log y is equals to log x by y. That is same. Similarly, log 9 minus log 5 is equals to log 9 by 5. So this is the second formula. Now third one. Third formula I am going to explain to you here. Log a is equals to base a is equals to 1. This is the formula number 3. Here what is going to say? Log 5 base 5 is equals to 1. Or you can say log 2 base 2 is equals to 1. Or log x base x also is equals to 1. Similarly, we will get that one. The formula, I think the three formulae you got it. Log x plus log y is equals to log xy. Log x minus log y is equals to log x by y. Log a base a is equals to 1. Now formula number 4. Now formula number 4 is log x to the power of m base a. Here what is actually log value is x. Log value is having certain exponent power, that is m, and base is a. Here what will happen? The power will become character. Character means m log x base a. That means the exponent will come in the coefficient of the log. The exponent became the coefficient of the log. The coefficient of the log only we can call it a character. So it became character. Now I will give you one example for this one. Log 512 base 2. And here interestingly, whatever the base value is there, this number also having same exponent of the base 2. So now what we can consider here? Log 2 to the power of 9, 2 to the power of 9 base 2. Here what is exponent? Here is 9 is exponent. So 9 will become character 9 log 2 base 2. That means 9 into log 2 base 2 is 1 according to formula number 3. So 9 into 1 is equals to 9. This is the formula number 4. Now comes the point of the formula number 5. Log x base to the power of m. Here base is having power. In the previous formula, the log value is having power. Whenever the base is having power, this power of the base, the exponent of the base will become reciprocal of the character. Reciprocal character. That means here we got the power became just m log x. Here 1 by m reciprocal of the character. 1 by m log x base a. That is the difference here. This is just m. If the log value is having power, it will become directly character. If a base value is having power, it will become reciprocal of the character. So that is our, and one example I am giving for this reciprocal character purpose. Log 3 81. 81 is nothing but a exponential form of 3. 81 is nothing but exponential form of the 3. I will show you here. 3 is here, the 3 to the power of 4. We can write 81 as 3 to the power of 4. 81 is equals to 3 into 3 into 3 into 3. That means 3 to the power of 4 is nothing but 81. 3 to the power of 4 is nothing but 81. Now we will write this one as 1 by 4 log 3 and base 3. Here which is nothing but 1 by 4 into 1 is equals to 1 by 4. So this is the formula number 5. Now formula number 6. Formula number 6 is log 1 base 5 is equal to 0. That means log value is 1, base anything is going to get 0. This is the formula number 6. Now formula number 7. Diagram of formula number 7. A log n base a is equal to n. That means whenever the base and character both are same, what are the log values here, that is going to be the final solution. Example I am giving here. 5 log 12 base 5. Here character value and base value is same, means here the answer is going to be 12. And these are the formulae you are going to face. Now next is some important problems I am explaining in this logarithms. Next is a few important problems I am giving here. You can see here log 8 by 27 base 2 by 3. Here you can easily identify. I told already. Here is 8 by 27. Here 2 by 3 means don't confuse by seeing the fraction number. Just the 8 by 25 is nothing but exponential form of 2 by 3. 8 by 27 always will be exponential form of 2 by 3. That means log x to the power of m base a. This is the formula. It's based on. That means m log x base a. That in a sense is 2 by 3 into 2 by 3 into 2 by 3. It becomes 8 by 27. That means 2 by 3 whole cube is equal to 8 by 27. Like that means log 2 by 3 whole cube by log 2 by 3. Here the exponent will become character. That is the 3, and log value is 2 by 3 and base also 2 by 3. And now 3 into 1. Why you got 1? Because log value and base value is same, or base it will be 1. So now 3 into 1, 3. This is the one more example. I think you got it clear? Now next sum is, in the first exercise, 9th sum I am giving here, 2 to the power of 2 plus log 3 base 2. And this is the sum is given. How to solve it, and you will purposely will get a lot of problem, but it's very simple case. What does that mean? 2 to the power of 5 into 2 to the power of 9 means what will it? Since the bases are same, power should be added. Here 2 to the power of 14 it will become. So according to this formula, and how it will be here, 2 to the power of 5 plus 9. 5 plus 9 is the powers are going to be added. Here the 2 having one exponent is 2 here, and less we kept means the base of the log 3 base 2 also 2 only. So that is the way we have to conclude. 2 to the power of log 3 base 2. That means we are plus we kept means whenever the bases are same, that time only we are going to get the plus here. So now here what will happen? 2 square means 4, and here this total value I am giving as a 3. Why I am giving the 3 I will explain here. How this R is calculated means because this is one formula here. A log n base A is equals to n. That means here character and base are same. Character is 2, base is 2. And what is the value of log A? 3. So that is the reason whenever the character base is same, whatever the value is there 3, that will come here. Oh, fourth is that 12. This is the answer for that one. Next, few important problems in the logarithms you are going to do. Expand log x cube and y square under root. How to solve this problem is very sincerely. Here one interesting point is there here. What is the meaning of the root means? Root is nothing but 1 by 2. Root value is nothing but 1 by 2. So here log x cube is the root I am converting as a 1 by 2. And here also root I am converting as a 1 by 2. Next step, what is going to happen here? Log here 3 into 1 by 2, x 3 by 2. And y into 2 into 1 by 2, 2 can cancel. Here final answer what is going to happen here? Log x 3 by 2 by 1, y only. Why? Because here 2 got cancelled. And this is the expansion form of the one important problem. Now we will go for one important essay questions now. Question number 5 in the exercise 1.5. Here one question is there. If x square plus y square is equals to 25xy, then prove that then prove that 2 log x plus y is equals to 3 log 3 plus log x plus log y. And here by taking the help of this x square y square is equals to 25x, he is asking to prove get this kind of logarithm formula. How? Means we will take the one formula a plus b whole square formula. That means here a is x, b is y, x plus y whole square. How will take x plus y whole square? Means very simple. X plus y how very simple it will be. X square plus y square plus 2xy. A square plus b square plus 2ab like that. In this case, we will continue this one whole square. In the place of x square y square, I am keeping this value here in the question. In the question, what are the values here? X square, y square is equal to 25. So now 25 xy plus 2xy. We are going to place. Now x plus y whole square is equals to 25xy plus 2xy. We are getting 27xy. Now, up to calculation is over here. Interesting point is, we have to show two log thing. That purpose, log, now we have to introduce the logarithm here. Now, in insert, here what is the step you have to say? Insert log on both the sides. Log on both the sides. That means log x plus y whole square is equals to log 27. This is the multiplication point of view. It will become plus log x plus log y. I separate logs are kept for 27 and x and y. Now here then comes to the point, because of this is the exponent, this will become character here. You can see here log x plus y, that became character. So here some conclusion we got. Now 27 we can write as a log 3 cube and plus log x plus log y. Now here see, I inserted the log and I separately kept for log value for 27, log value for x, log value for y. Now what I did, the exponent became character here according to formula number 3. 2 log x plus y is equals to, and here what is happening here? 2 log finally x plus y, 3 log 3 plus log x plus log y. This is the final answer. Log x plus log y. All the steps here because of this one. First of all, you have to take one formula here, a plus b whole square formula, a square plus b square plus 2ax, and here we are in the place of x square and y square, we are taking the this is the x square and y square value, 25xy plus 2xy, it becomes 27xy and log x square. Now he asked to prove that one log 1. That means we have to insert the log here compulsory. We are inserting the log on the both sides. Log x plus y whole square, log 27. Because of multiplication, we are adding the plus mark here. Log 27 plus log x plus log y. Now, according to formula number 3, the exponent will become character. So, 2 log x plus y is equals to 27 we can write as a 3 cube, log 3 cube and log x and log y. Now finally 2 log xy, the exponent of this log, this one became character here, 3 log 3, log x and log y. This is a solution of the sum number 5. Now sum number 6 will go. Now sum number 6 here. What is that sum number 6 means? You can see if log x plus y by 3 is equals to of log x plus log y of into log x plus log y, then find the value of x by 5 plus x by y and y by x, and it is asking here. You can see if the log x plus y by 3 is equals to 1 by 2 log x plus log y, then is asking find the value. He is given this one. With the help of this one, you should bring the value of this same thing else. Now I will give the solution very simple way. Try to concentrate. This is very important long problems. So first of all, we will take log x plus y by 3. Very simple manner. Here I told you already. Second, in this step, in here on this side, we are not going to change anything else. In the right hand side, in the left hand side, we are going to change little bit. That log x plus log y according to problem number 1, I am writing as a log xy. Now, one more change in the second step only I am taking. X plus y as it is. Here, 1 by 2 means, in the previous sum I told you, 1 by 2 is nothing but root, the value of root. So this 1 by 2 I am converting as a root here. Log x, xy is there. This 1 by 2 I am converting as in the form of root. Now in the previous sum, we added logs. Now we don't want the logs here. Why? Because we have to prove this one. What is the x by y plus y by x value? That is the reason we must remove the logs. So now I am removing the logs here. What is I am going to get means x plus y by 3 is equals to under root xy. Now cross multiplication is going to happen here. In this cross multiplication, x plus y is equals to 3 under root xy. Because of the root, we have to go for squaring on both the sides. Here one step you have to keep squaring on both the sides. Both the sides. That means x plus y whole square is equals to 3 under root whole square. You can glance here, very simple. First one, this is the, according to the question, what is the data is given, we have noted. Second thing is, log x plus log y is converted into log xy. Then this 1 by 2 I am converted as a under root here. It will become root for the both x and y. Then I remove the logs here. You have to click on statement, remove the logs. I remove the logs here. Now after removing the logs, what it became? X plus y by 3, which is equals to under root xy. Now cross multiplication, xy plus 3 under root 3. Now because to remove that what is called square point of view, squaring on the both the sides. Now next step is x plus y whole square is equals to 3 means 3 square. Here square will be going to be get cancelled. Here 3xy became. Now what we are going to do here? This is what it becomes. X plus y whole square means x square plus y square plus 2xy is equals to, here 3 square means 9xy. Now what we will do here, x square plus y square is equals to 9xy. This 2xy will go to the other side, it will become substituted. Then what is the solution here? X square plus y square is equals to 7xy. Now finally I want what is the value? X by y plus y by x is what is the value of this one. So we have to bring that one means we have to remove certain variables here. How to remove means divide this equation, divide the equation by xy. Why? Because here one constant number I will get. So I am dividing here x square by xy plus y square by xy is equals to 7xy plus xy. Here I removed. Here I am cancelling this one, and what I will get here? X square by xy plus y square by xy is equals to 7x by xy. So xy got cancelled here. What is that here? 7 only left. Here x square I can write as x into y plus y into y by xy. Here y get cancelled, x get cancelled. What is that now? X by y plus y by x is equals to 7. That means you can see very carefully here. Here squaring on both the sides means we got here x plus y whole square and 3 square root we lost, and now 3 square xy means 9xy becomes x plus y whole square means x square plus y square plus 2xy. Now what is happening? This 2xy I am sending other side. So x square plus y square is equals to 7xy. Because on constant number we are dividing the same equation by xy, and after dividing we got finally we can see x square I can write as x into x, y square I can write as y into y by xy. Here and xy. Here x cancelled, here y by cancelled. What is left now? X by y by x. Finally he asked what is the value of x by y plus y by x is nothing but 7. Now next problem. Now next important problem is 7th one. If very important problem, if 2.3 to the power of x is equals to 0.23 to the power of y is equals to 1000, and then find the value of 1 by x minus 1 by y. This is the question. Once again you see the question carefully. If 2.3 to the power of x is equals to 0.23 to the power of y is equals to 1000, then find the value of 1 by x minus 1 by y. Now solution is, first of all we'll take relation of this 2.3 x whole to the power of y. 2.3 is equals to 1000. Next step is 2.3 is equals to 10 cube. 1000 I can write as a 10 cube. Next 2.3 is equals to, this exponent I am sending the other side, it becomes 3 by x. So this is equation number 1. And now I am taking the relation between 0.2231 in this one. Now second is 0.23 whole to the power of y is equals to 1000. 0.23 to the power of y is equals to 10 cube. Now 0.23 is equals to, I am sending this exponent other side, it will become 3 by y. Now 0.23 is equals to 10 to the power of 3 by y. This is equation 2. Now I want to show certain relation between the equation 1 and equation 2 here. You can see what is the relation between equation 1 and equation 2 is 0.23 is equals to 2 by 3 by 10. That means if we are dividing 2 by 3 by 10, we will get 0.23. I want to utilize this value of the equation 1 and value of the equation 2 in the same equation. So I am combining. In this place, now in the place of 0.23, I am keeping the value of 0.23, that is equation 2. That is what? 10 3 power of 3 to 3 by y is equals to, in the place of 2.3, I am taking the value of equation 1, 10 to the power of 3 by y. And already down 10 is there, that is 10 to the power of 1. Now, because all the bases are equal, I want to make all the bases are equal. Now, what is happening here? 3 to the power of y is equals to 10 to the power of 3 by x, and sending the this one is up, and 10 to the power of 3 by y is equals to 10 to the power of 3 by x minus 1. Now, since the bases are same, since the bases are same, powers should be equated. Powers should be equated. Equated. Now 0.23 is equal to 2 by 3 by 10 here, and so now what I am going to do, because of the all the equations are same, now here once again I am placing here 0.23 in the place of 0.23 I am writing as 10 3 by y here, and in the place of 10 what you call 2.3 I am writing as 10 3 by x and by 10 to the power of 1. Now what I am going to do here, 3 by y equal to, this one I am sending up, 3 by x minus 1. Since the bases are same, power should be added, I told you here. Now 3 by x is equal, 3 by y is equal to 3 by x minus 1. Now I will send this to the other side here, then minus 1 will become this side. 3 by x minus 3 by y is 1 is equals to, or we can say like that, 3 by x minus 3 by y, we can write like this also. is equals to 1. And since the numerators are same, I am taken as common. Now 1 by x minus 1 by y is equals to 1, and 1 by y minus 1 by x is equals to 1 by 3. So now, and finally, what is the value of 1 by x and 1 by y means we got 1 by 3. Check properly. I think hope so you got a good rhythm here, and few more problems left. Before that, we will go for little break, 5 minutes break. I hope so. If you are confident about my live explanation, come back once again very quickly after 5 minutes break. Now, the next important concept is I am going to explain HCF. and LCM. How to find out? Most of the people will get confused over here. HCF and NCF. Here we having the 4 steps to calculate the HCF and LCM. What is the first step is express the given numbers. Express the given numbers in exponential form. Exponential form. Express the given numbers in exponential form. Here also in LCM also same. First step is step number 1. This is step 1. Here also step 1 is same as it is. Express the given numbers in exponential form. Here step 2. Take common basis. Take common basis. Take common basis. Here take every base. Take every base. All the bases you have to take here. Take every base. Here take only common base. This is the important point you have to concentrate. First point is, first step is both LCM and HCF is same. Why? Because express the whatever the given numbers you got. With example I will show you. Very carefully note down these points. Very carefully note down. With example I will show you here down. Step number 3. And assign the smallest. Assign the smallest. This is another important point. Smallest exponents. Assign the smallest exponents. This is step number 3. Here also assign the not smallest here. Assign the greatest exponents. Here assign the greatest exponents. Here greatest exponents you have to take. Here smallest exponents you have to take. And step number 4 is very simple. Take the product. Take the product. Take the product. Now I am taking the two numbers here, 72. That means here the question is find the LCM of 72 and 108. Find the LCM of 72 and 108. 108. How to take means, first of all you have to take the exponential 72 in exponential form and calculate the HCF, then I will calculate LCM there. Here 72 is 2 to the power of 3 and 3 to the power of 2. You will get it. And 108 I am taking the exponential form here. So here is 2 square into 3 cube. Now both 72 and 108. What is the HCF of 72 and 108 means? 72 and 108 should be converted into exponential form in both the cases. In case of HCF, in the case of LCM is same thing you have to do. Here also same time I will do here. 72 is equals to 2 cube into 3 square. Here 108 is equals to 2 square and 3 cube. Both the cases, the question is 70. Find the HCF of 72 and 108. Find the LCM of 72 and 108 means the 4 steps I gave in HCF, 4 steps I gave in LCM. What is the first step? First step is common in the both the cases. Express the given numbers in exponential form. Express the given numbers in exponential form. Second step is different. Here in HCF, take only the common basis. Take only the common basis here. Take every base here. Take here every base. Now here, assign the smallest exponent form. I will show here what is the smallest exponent form and what is the greatest exponent form. Finally, fourth step is same in the both the cases. Take the product and take the product. Now, and what else here? Here assign the smallest. Here two common. Here what will take common bases? Here common bases are there. We got here also common bases. Here also common bases. But in this, when we got the common basis, according to step number 3, step number 4, we have to take only the smallest ones. Here in common basis, which is the smallest? 2 square is smallest than 2 cube. So we have to take 2 square. He told us the smallest one. 2 square you have to take. We should not take the 2 to the power cube. Why? Because this is not the smallest. This is the biggest, this is the smallest. In the common basis, Here common basis also. Here we take smallest. Smallest is 3 square, not 3 cube. So here 3 square. Now 2 square means 4. 3 square means 9. So 4 into 9, 36. So what? Finally what? HCF of 72 and 108 is 36. What I have taken? Here 2 cube is there, 2 square is there, these both are common, these both are common. But only we have to take smallest ones. That is a concentrate here. Smallest one to take. Smallest is in the 2 cube and 2 square, which is the smallest? 2 square. In the 3 square and 3 cube, which is the smallest? 3 square. So smallest ones you have to take for HCF. Greatest ones you have to take for LCM. Now we are taking the greatest ones here. You can see here common one are there. Every base you have to take here, not common. Every base you have to take here. But finally what you have to take? Greatest exponent. In this, which is the greatest here? 2 cube is the great. 2 cube is the great. And in the 3 cube and 3 square, which is the great? 3 cube is the great. So now 2 cube means 8, 3 cube means 27. So finally 216 will come. 8 into 27 means this is the LCM of 72 and 108. This LCM and 72, 108. So this is the outcome point of the HCF and LCM of 2 or more numbers. These are 4 steps you have to remember and follow this method. You will become you will get easy both in the case of HCF and LCM. Once again, exponential form. What are the numbers are there? The numbers you express in exponential form. Here also exponential form. Second, you have to take only common bases. Only common bases you have to take. Not common ones we should not bother. Here every base you have to take. Every base you can take. No common ones. Here the smallest exponents only you have to take here. Here smallest I took here. There greatest ones I have to take. And finally take the product of the selected smallest ones. Take the product of the greatest ones. And here LCM of 72 and 108 is 216 and HCF of 72 and 108 is 36. Now the next 1.2 exercise. This is I will show you very important problem. This one, prove that 3 plus 2 root 5 is an irrational number. Irrational number. You have to prove this is an irrational number. And what is the question meaning is already this is irrational number, and is asking what is the evidence, what is the proof, what are the steps you will show that is compulsory, it is a confidently it is a irrational number. So first of all, to prove this as an irrational number, we have to think this is a rational number. Before proving this, is already the question is given. 3 plus 2 root 5 is an irrational number. But before proving it is a rational number, you consider this one as a rational number and start. Now first step is solution. First step is on contrary. On contrary means, why you are saying on contrary? Irrational number 1 I am taking as a rational number. That purpose you are saying the word on contrary. On contrary, let us assume that 3 plus 2 root 5 is a rational number, is a rational. That means you are considering this is 3 plus 2 root 5 as a rational. That is not really rational, we are taking rational. To prove finally, to prove experimentally, statistically, to prove this number is irrational point of view, we must consider as a rational. మనం అది రేషనల్ అనుకోవాలి. మనకు తెలుసు ఆల్రెడీ ఇది ఇర్రేషనల్ అని తెలుసు, ఇది ఇర్రేషనల్ అని తెలుసు. కానీ ఇర్రేషనల్ అని ప్రూవ్ చేయాలంటే మనం ఫస్ట్ దీన్ని రేషనల్ అనుకోవాలి. ఫస్ట్ దీన్ని ఏమనుకోవాలి? రేషనల్ అనుకోవాలి. నౌ సెకండ్ వన్, therefore 3 plus 2 root 5 is equals to p by q form. That means ఎందుకు p by q పెట్టాను? Because I am considering this is a rational. That purpose I kept the p by q. P by q keeping means it is a rational. Okay. Now second step, 2 root 3. I am sending this 3 to the other side. P by q minus 3. And this is I will get as a LCM cube. After LCM, it became p minus 3q by q. Now next step is 2 root 5 is equals to p minus 3q by q. And whatever the sum is, next I am sending this other one also. One more step number. This is the step. First is on contrary. Let us assume that 3 plus 2 root 5 is the rational, and we are considering this is the rational. And this and this 3 I am sending the other side, it became negative. After taking the LCM, we got p minus 3q by 3. Then we got the final equation. The next equation is I am considering here root 5. Here this 2 also I am sending the opposite side. Root 5 is equals to p minus 3q by 2q. That means whatever the 2 I send this one is became. Now this is the condition. Here what happened? Here see, once again, on contrary, let us assume that was so and so, we got this one. Here, after this one, this is the final equation, but we have to see comments here. What are the comments here after these steps? Since P and Q are integers, p minus 3 by 2q is a rational number. Why I am considering this is a rational number? Why? Because this is in p by q form. This is a rational number, but this is not rational number. This is not in p by q form. This is a p by q form. So now what is happening here? This contradicts. This contradicts. Next step is this contradicts this contradicts our assumption. What we assumpted? We assumpted that one, our assumption 3 plus 2 root 5 is a rational number. Rational number is a wrong one, is a wrong. Finally, we will consider that 3 plus 2 root 5 is an irrational number. Now, one sum we are I'm writing here, right? X log 9 base 2 in exponential form. In this case, how to write this in exponential form is first of all you are saying here see x log 9 base 2. What will happen? And this actually become the power of the base now. 2x is equals to what is log value? 2. So now here according to which formula it becomes x is equals to log n base a. X is equal to log n a. According to this formula, ax is equals to log n. So here log n is 9 and ax is the 2x. So this is the exponential form expression is 29. The next one is and now next is some important problems here. You can see find the value of log 128 base under root 2. This is very interesting one. Log 128 base is under root 2. How can we convert this one into base? Here log 2 to the power of 7 base under root. We can convert this one as a log 2 to the power of 7 base 1 by 2. Now base is also having power and log is also having power. Base is also having power, log is also having power. Now the power of the log value is 7 log 2 and base 1 by 2. Next step is the power of the base becomes the character here. Character means reciprocal character. Actually it has to 1 by 2, but 2 by 1. 2 by 1 into 7 into log 2 into base 2. See here carefully. 125 are converted as a 2 to the power of 7 and under root as is. Here the what you call the exponent became the character of the log here. 7 log 2 base to the power of this one. Now the power of the base became 2 by 1 here into 7 and log 2 base 2. Now 2 by 1 into 7 means 14. 14 into log 2 and base 2 according to the power number 4 is 1. So 14 into 1 is 14. So this is the interesting solution of the first one here. Okay, and okay, next sum is now another interesting sum is write any two irrational numbers, write any two irrational numbers lying between three and four. Lying between 3 and 4. Now, how to solve this problem is very simple one. 3 we got from root 9, and 4 we got from root 16. 3 we got from root 9, 4 we got from root 16, and between root 9 and root 16 we are having some values. What are the values? Root 10, root 11, root 12, root 13, root 14 and root 15. That means here is root 9, we having root 9 here, 3 we got from root 9, and 4 we got from root 16. And here is root 16 we having. So between 3 and 4, what are the rational numbers are present means rational number 1, 2, 3, 4, 5, 6 rational numbers are there between 3 and 4. Between 3 and 4, 6 rational numbers are there. What are 6 means? Here root 10, root 11, root 12, root 13, root 14, root 15. So that is what is the 3? Root 9. What is the 4? Root 16. Between these two. And next important sum is next one. Here two concepts I am saying here. The product of two rational numbers always irrational numbers. the product of two irrational numbers. Two irrational numbers is the product of two irrational numbers is irrational number. Is a rational number. Is a rational number. Rational number. This is very interesting one. That means when you are multiplying two rational numbers, you will get one rational number. That is the concept one. Second thing is, one example I will give for this one. Root 2 is an irrational number, first irrational number, and root 50 is the first irrational, second irrational number. Now, first irrational number is root 2, second irrational number is root 5, root 50, and then what is the product means? Root 100. We will get as a root 100 for this product, and root 100 means nothing but 10. So 10 is a rational number. So whenever we are multiplying two irrational numbers, we will get one rational number. This is the example for that one. Now, second one is the product of the two irrational numbers. Two irrational numbers is an irrational number. Don't confuse here. Very, very carefully you see. I am taking here one first irrational number is 2, second irrational number is 50. Root 2 into root 50 is root 100. Root 100 means 10. 10 is a rational number. That means when we multiplying the two irrational numbers, I am getting one rational number. But second case you see, when I am multiplying the two irrational numbers, again I am getting irrational number. Don't confuse this one. When I am multiplying the two irrational number, one rational number we are getting. So that means according to the conditions. So root 2 is a irrational number, root 50 is a rational number, and product is root 100, which is nothing but 10. 10 is a rational number. So this is proved. Now this one is the product of two irrational numbers. First irrational number is 3, and another irrational number is 7. When I am taking the product of these two, root 21. This one also irrational number. Irrational number into irrational number, irrational number. Irrational number into irrational number, rational number. Irrational number into irrational number is irrational number only we are getting. And irrational number into irrational number, rational number we are getting. In the first case, two irrational numbers bringing the rational number. In second case, two irrational numbers bringing the irrational numbers. Now, two more interesting problems I am giving you before completing the rational numbers product. I hope so. This concept you are understood more, and put your comments and suggestions also, and praisings also, everything else also in the comment box. That will give you boost in many subjects I want to give. In physics also I am ready to give in the future. And mathematics will build up, and I think next week in mathematics I am going to give polynomials, very important topic. And before that, now I am concluding that one, two sums are there, very carefully go through. If HCF of 306 and 257 is 9. The HCF of 306 and 257 is 9. Then find their LCM. Then find their LCM. He is given two numbers. That means A is equals to 306 and B is equals to 257 and HCF is equals to 9, and for asking the LCM is how much, and one formula is there here, HCF into LCM is equals to A into B. Here is the HCF is 9, we don't know LCM, we have to find out. LCM is equals to so and so, and the numbers are 306 is the A and 257 is B. Now therefore LCM is equals to 306 by 257 by 9. 9 in the 367 is go 34, and finally you are going to get LCM is 22,000 22,338. That is the LCM of this one. This is the formula. HCF into LCM is equals to A into B. Here A is 306 and B into 257, and the LCM is we got 22,338. Then the last sum before completing this real numbers live. Carefully listen, very important sum. According to the latest format of the sum, you can see now. Now, find the numbers. Find the number of digits. Number of digits. Find the number of digits in 4 to the power of 2023. Here 2023 why I kept means because this is the year, the present year, 2023, the present year. So that is the power of that one. If log 2 base 10, the log 2 base 10 value always given 3010. Now how to calculate this one means you can see here 4 to the power of 2023. I can write as 4 I can write like 2 to the power of 2 into 2023 is equals to 2 to the power of 4046. 4046. Now according to the program, log 2 to the power of 10 2046 is equals to here the according to the formula number 3 log x to the power of m base 10 means this is the power will become calendar year 4046 and log to base 10. Here log to base 10 value already we got here. Log to base 10 value already got here. What does that means? 4046. This is the log to base 10 value is 0.3010. 0.3010. Now this is the log value. We are multiplying this power exponent becomes, and here after calculations it will become 1217. So this is the end of this problem. I think, my dear viewers, this live stream, if you are really enjoying and really interesting, if you are with your support, I will come back with all tough chapters, every chapter like trigonometry, similar triangles, everything else in the your mathematics and in the physics topics also. I am coming very soon in front of you, and support me with this. If you likes this live stream in future, next Sunday I am coming with the polynomials, and more views I want from your friends also to support my live streams in future knowledge bank. Will give you the best knowledge.